So now we're moving on to talking about ANOVAs, and this video focuses on the one-way ANOVA. And specifically, this is going to be a between subjects measure. So we're going to look at a simple one-way ANOVA today, or right now, and we're looking at for the nature of the independent variables. We still have just one independent variable. And it has two or more levels. So I mentioned that you can run an ANOVA for 2 levels. Really, you only use it if you have 3 or more. So 3 or more that are independent groups is what we're talking about. We still have one dependent variable. And so we're going to conduct a one-way ANOVA. So just as a quick reminder, we do have within subjects factors, which would be repeated measures. We also have between subjects factors. You can also combine these, but we're not going to worry about that right now. So what we're talking about right now is we're looking at participants only being in one treatment. There being differences between the groups here. So we're going to go ahead and do this in SPSS, where participants are only in one treatment condition. And I know I just used the word treatment condition, but condition is more what we're talking about. So in one group or category. So here we are using the exam grades data. And what we're looking for is how we would conduct a between subjects one-way ANOVA. So we're looking for independent groups. You could turn like attendance. We talked about this in class. You could turn it into a 3-level variable or more than 3 levels. But you typically don't want to do that because then you lose some of the quantitative information that you're getting here at this ratio level. So in this data set, we have gender. We have 3 levels. Isn't that convenient? So we can look at our values and we can see there's woman, man, and non-binary. Well, that's 3 levels. We could use that for our independent variable. We also have exam score 1, exam 2, and final exam. And we are going to anticipate that these are all the same. These are all the same exams. They're just being taken 3 times. Now we have our attendance. So we could compare for our dependent variable. We could choose any one of these. We could look at any of these. So we're going to go ahead and use gender as our independent variable. It has 3 levels. They're independent from each other. You can't be in the woman category and the non-binary. You're in one of them. And there's not a relationship between them. And let's look at attendance. Let's see what that looks like. So I'm going to go to Analyze, and I'm going to choose Compare Means because we're still talking about comparing means here. So all of our null hypothesis tests so far have been comparing means. And we're going to choose a one-way ANOVA. Now here we refer to our group. Instead of having a grouping variable, we're going to call it a factor. So our factor is gender, and it's not going to work as a factor unless it is set as a nominal level variable. Notice that we do not have to identify the number on that we're comparing like we did for the t-test because it's going to check all of them. Now remember, this is an omnibus test, so it's going to look for relationships all over the place. And we're going to choose our dependent list. I'm going to right click here. Oh, there we go. Display variable names. And I want to do attendance, so I'm going to move that into my dependent list. I could check them all at the same time if I wanted to, but I'm not going to worry about that. I do want to estimate effect size for overall tests. I also want to look at a post hoc. So post hoc, because we're doing an omnibus test, it's going to test all of the relationships. It's going to look and see if woman has higher attendance than man or non-binary or just different attendance, right? But then we need to do a post hoc to see where the differences are. So I'm going to choose Tukey, and I'm going to say continue and OK. And you can see that up here is, you can double click into it. I can copy this syntax again. So here is our syntax for our one-way ANOVA, and let's interpret this. So we did a one-way ANOVA, and we're looking to see overall is there a difference in attendance between our three groups? So we have some information on our sum of squares, our degrees of freedom, our mean square. What we're looking at, what we're interpreting, we're looking at this F score. So we're now in an F distribution instead of a T distribution. And we're looking for significance as well. So we have a lot of information here, and we really want to identify inferentially what we're learning from this test. So our F statistic is 0.47. It's pretty small, and our significance is 0.63. So our significance, is it less than 0.05? No, that is our p-value. It is greater than 0.05, so we fail to reject the null hypothesis. So what that tells us is that overall, there's no difference in attendance, because that's what we compared it, across these three levels of gender. Now, part of that, if you look at our information here, you can see that we only had 2 people who identified as non-binary, 7 who were men. Those are really small groups. And so that's really too small to be able to look at the differences there. But we can get some useful information here. So we calculated our eta squared, which is our point estimate. That's our effect size. That's really small. 0.038 is really small. And then our post hoc. You really only need a post hoc if this is significant. It's not. So it's not going to give us any new information, but you can see here that if you compare woman and man, the mean difference between those 2 groups on attendance is negative 0.512, gives us our standard error and our significance, so our p-value, and then our confidence interval. So you can see here that none of these are significant. And I knew that would be the case. As soon as this is not significant, we're not going to find significant differences between groups if we don't find it here. But it's nice to run it ahead of time. So you could always not run it until you know you have significance. This, again, just a reminder that with our confidence interval, we're crossing 0. So our lower bound and our upper bound are around 0. So that means that that's also just an indication that it's not significant, because it's basically saying that a possible true value is 0, no difference. And that's our null hypothesis. So that is how we interpret a one-way ANOVA for independent groups. And again, you can play around with your syntax. So you could say, you know what? I actually don't want to calculate my post hoc test. So I'm going to take out my post hoc equals 2p alpha. I'm going to delete that. And I need to make sure my period is still at the end there. If I run this, you'll notice that now it's a lot smaller. I don't have any Tukey in there. I don't have a post hoc analysis. I could change my confidence interval. I could say 0.9, and I can run this again. Look at that. It's a 90% confidence interval. So we'll again talk more about confidence intervals later, but don't be shy in playing around and seeing what happens here. So that's the end of this video, and the next video is on repeated measures ANOVA. And that's all I have for you on this one.